practical effects studio coming from Stan Winston, and we were approached for a video game campaign for Halo diorama. I don't know if anyone's ever seen it, but what they wanted from us was a frozen moment in time of a battle. And it was about a 3.5 week deadline, hundreds of characters, fully finished, to be put on a 40-foot diorama to be shot in many different angles, all spun around with some beautiful music. Traditional sculpting would not have done it. We would not have been able to deliver the job. We didn't want to let this job go. We knew it was a very high-profile campaign, so we decided to jump into 3D printing. My whole idea was, we're not going to go buy a printer because we could fail miserably and lose even more money, but we're going to work with a service bureau to learn about this technology, to see if what we see on screen can be delivered in the final output. We can learn from it, deliver this job, and it will be our test bed to change the way that we work in the future at Legacy Effects. So you can see some stills right here of what we had going on, tons of characters, and we gained so much time back from design after going through the service bureau that we were able to rework a lot of these characters and actually go back to the agency that hired us, scan their faces and put them into the commercial as well. We could bring it more to life. All this valuable time that we're gaining back. So about 3.5 weeks later, we came up with this commercial, which won numerous awards. Any one of our artists, any one of our designers is free to use any package that they want to model in. We are not going to limit an artist and tell them you need to use this, not that. On top of what they want to use, we will give them some requirements to funnel back into the pipeline and workflow that's going to work for the delivery schedule that we need. So we allow them, once they finish their modeling in their CAD data, to then go through another version of Pixelogic for detailing and texture, and then to finally prepare files with Materialized Magics, getting watertight, getting ready for printing, breaking up booleans, keying, things like that. So we knew that's how we were going to set up the artistry. From there, we work with actors and actresses all the time, and we have to put suits on them, make armors and wrap around people, and a lot of times even on commercials, because this isn't just for feature films. We work on commercials as well, which are very quick deadlines, a couple of weeks at a time. I believe in 2010 we worked on 220 commercials as an example. We needed to be able to be one step ahead with concept design. And what did that mean? Well, a lot of commercials, they don't cast someone until the very last day before the shoot. So we need to know what we're going to design around ahead of time. So if they don't cast anyone yet, we can't work. But if they know what they're going to cast, as far as measurements, if the person's going to be 5 foot 10 inches, we can start working ahead of time before a person even gets cast in the commercial. So I came up with a couple of my friends a way to manage all of our in-house scan assets. So for instance, if an artist knows they're going to need to make a helmet or a suit to wrap around someone that's 5 foot 10, 180 pounds, has a forearm diameter of a certain proportion, we can plug it into the system and reduce down to all the people that we have on file that we can use as temp to design around and keep moving forward. So as you can see here is an overview of our visual asset system, all different head scans, body scans, and once we select what we want, if it's data that we've used before, I can throw it right to one of my machines. I can put that right there, clean it up, and just Christmas too, ready to go to apply stuff on top of it. So that was a great way of working. We didn't want to go look on a server in a past project and we find someone that looks like this. No, it's all there at our fingertips. Let's find it right away and keep working. We don't want anything stopping us. Creativity should keep going. So that's in place, so it's working nice for us. Next challenge is our assets, even though we make these suits that you see out here, it doesn't stop there. We hand over that original asset to a visual effects team such as ILM, or Digital Domain at the time, and they use that asset for their starting for the digital portion of the film, which means that the assets that we have are huge. Machines cannot handle them. If anyone here prints on the machines that you see here, you know what it's like trying to slice up high-res geometry. It's just not going to work. So we needed to find ways of decimating down data and maintaining the original crispness, what the director saw on the screen, what they approved and signed off on, and can I represent that in the print? So for instance, here you see in ZBrush, this was for Life of Pi with Ang Lee, and we have an orangutan that's modeled up and it's very high resolution. And after decimation underneath of it, you can still see it still has all of that texture there, but it doesn't stop there. Can I keep that texture across on my machines by doing my maintenance and daily calibration? And if you look on the right, it's all represented. It's lost the workflow that we have set up. And this is an automatic process for us. So, all the puzzle, pieces to the puzzle are fitting in. This is our workflow. It's starting to work really nicely for us. The main important thing here is the artists are comfortable. The artists are not scared about technology and trying to figure it out on the fly. They can just do what they need to do. So, we brought in that Eden 260B. For 2 years, that was the only machine that we had, 10 inches by 10 inches by 8 inches deep. And we created some of the most iconic pieces ever on that machine, and people are still blown away with what we've done with just a 10-inch square body, which is a pretty small machine. So for instance, this is a final output painted of off of the Eden, of one of our collectible series. And if you look right there, that's a final product. That's beautiful, there's no loss of resolution. We now break things up for manufacturing purposes and casting purposes, being able to keep things, learning how we can keep things on seams, on muscle joints. Taking it one step further, we're actually modeling in digital fabric rolls on top of things that we can then wrap real fabric and texture over so you can simulate the real looks of the ocean and just the proper proportions. And what does it look like at the end of the day right off the printer post-process? I think it looks pretty good. So this is working for us. We're getting sign-offs to go full size based on 18-inch requests and collectible series, and without losing any data, without losing any resolution. Making deadlines is the important part, because you notice that was 2008. 2008, we were pretty much in a recession. allow us to keep up with today's current state. We went from a practical hands-on studio to what we consider to be a hybrid effect studio now. So, this example that I'm going to show you here is what we're able to achieve in resolution based off of a film production asset. And it still blows me away because the print that you'll see here I did 6 years ago without any manufacturing tools whatsoever to help us prepare this file. So this is right off of the printer 6 years ago. And if you look at the detail, that's a one-piece printer. So this technology, you can print at 16 microns, basically 0.006 resolution. All of the extruders here print at 0.1 resolution, right? So I'm printing at 0.006. It's one thing to print it at 0.006. How do you clean it at 0.006? So we find what's not possible and we try to figure out how can we work around the limitations of technology now. So before even having a program like Materialize Magics, we needed to figure out, think ahead. We're going to need to clean this with its own support material. So if you look at the bottom of it, I'm going to go back a slide. You see the spider web down here? That's all in version 2 of Zebra Z-spheres attaching to the bottom of all the braids because we know what it's going to be like to try to clean this. It's going to break and fall apart and damage. So we're modeling extra support material by ourselves 6 years ago to clean this head and then just snap them off at the end and call it a day with a final material. So without having the tools at first to prove these things, now we're getting the partners of our company saying, you guys are doing it, and telling us that a program out there that does it, here's the money, go buy it, so we don't lose even more hours with you guys trying to figure it out. So we're proving that we can do this stuff. So, we're still on that little machine, and we want more, and the artists are really getting into this because they're seeing firsthand all their hard work on these monitors from day to day to day being output right in front of them now, and they're seeing their visions come to life. So the next project, that we're going to do is on the first Iron Man movie. We paid so much attention to making the suit in SLA, and it was the first of its kind to be done like that, that we ran out of time and we had to go traditional with the gloves for Robert. Traditional foam latex gloves, and it was kind of a letdown for us internally because the suit is so beautiful, so we're like 99.9% awesomeness, and that one little part that we wish we could have changed, we didn't have the time. So when Iron Man 2 came out, we were approached saying, how can we make these gauntlets the way that they were supposed to be? So the only way to do it was 3D printing. So we broke down all the gauntlets for all the Iron Man suits in the second movie and broke out all the digits. And the real cool thing was there was no other way to do this. Because inside of each digit is a curved 20-valve channel that connects them all together and then we cable them together on the back plate of the palm to be able to articulate. On a curve 20 thou. There's no other way to do it. So we did this concept in about a week and a half with Ian Joyner, one of our lead artists, and Brian Hahn, a mechanical engineer, and assembled them together and came up with, you can see the linkage going through here. Curvature runs all the way through, and we took a polyjet piece and we basically sanded up, primed it, metal etched it, and then sent it out to be nickel plated to give it even more strength. And at the end of the day, we had the first articulated gloves ever of a 3D printer that actually went in front of the camera and were used on Robert and everyone else in the cast. And what was great about it is I was getting phone calls from Shane on set saying, we need another left and another right. Can you make more copies for us? Can you make more copies for us? It was a 13-hour print to do a left and a right every day, and we were just feeding the plater and assembling gloves and having these beautiful gauntlets that are still in my office today holding up, and people still wear them. And I think Allison even borrowed a pair from me to go work on a project that she was trying to do. And it's just a beautiful thing, because to this day, these gloves are still there. And that was how we were changing all of our workings and moving forward with what 3D printing can bring to the table for us. So, what can we do even more with 3D printing? Well, can we show a concept design, turn it into 3D data, print out a maquette at a small scale to get approval to go full scale? Well, I think we can, so let's try it. So we break down a Photoshop sketch with many artists throwing in 3D data and modeling it up for us. printing out very high resolution pieces of atom that you just saw in that concept within a week. Getting them to 18 inches and fully painting them and lighting them, and even bringing in clear printing parts in the logo and lighting that, and you can see all the detail and the finishing that Trevor put on it. Get the approval from Sean in the studio to go full size. And we don't have enough time for me to show you the full-size builds, but I can show you the first time that they saw their full-size builds that all have RP parts on them, SLA, Polyjet, FDM, and the traditional CNC mill parts and build parts as well. And it all come to life. So this is the first time everyone was seeing these characters come to life with RP parts. A lot of them are hydraulically driven, rod puppeted as well as remote controls. And by using 3D printing technology, rather than our hands to sculpt and make these pieces by hand, we now gain back time that we can put into now bringing Arduino into the mix and programming things and bringing more automation and really programming and bringing characters to life because we've gained time now in development because we're not sitting there working by hand. How can you sculpt symmetry by hand? You can't. So a lot of times we work on the left side and then just mirror it on the right side and it's print. Pretty phenomenal. That's all I saw. So it's starting to work and everyone's starting to see this is kind of like our new business model, how we're doing things. We will still sculpt by hand. We don't turn our nose against that. That's what got us to where we are. If we have the time to do it, we will do that. And a lot of times I'll take a traditional sculpt now and digitize that into the computer, and we'll throw 3 more artists on top of that to make 3 more versions of it. So it's a beautiful workflow that we have going on here with the mixing of all this artistry. So now we're having fun with this stuff because it's coming to life, and now we're having little challenges that are popping up, and people are coming to me saying, can 3D printing help with this? So we worked on a movie a few years ago called Cowboys and Aliens, and in the hero alien head, we had a problem with the upper and lower teeth that they wanted inside of the main puppet. The first problem was there was no way to mold the amount of detail that they wanted in these teeth. The second problem was there possibly was going to be a little child arm inside of the teeth that was going to be hydraulically opening and closing, so if it was done in the rigid material, something bad could happen. And 3, even if we got rid of the child part of the equation, the amount of PSI from the hydraulics opening and closing the mouth was going to shatter whatever material that we had because of the detail of the teeth. So can we print in rubber, flexible parts? So I was working with Israel and it was still object until they were in Stratasys, and I was like, I need to be printing in a rubber-like material on my little printer. And they said, well, we have a problem with the material because it needs so much UV that it's actually baking in a yellow tint to it. And I'm just like, I don't care about the yellow tint. I care about the flexibility because we can work around that yellow tint. I have the most amazing artists in the world that will figure out how to dye this stuff, how to work with it. Please release it from R&D and give it to me, get it in my hand. So they finally gave it to me. And that's the first rubber print years ago on a little machine. And you can see they were correct. It has a yellowish hue to it. But I handed it over to Christopher Swift, who's our lead artist at the studio, and he was able to turn them to look like that. And that was accomplished by us on the undersides of these things, just channeling and pulling in like little guides and tubes that we basically injected ink and all different dyes into, and then did different styles of painting on top of the rubber-like parts. Beautiful detail. It might be boring, but that's a beautiful piece of a rubber 3D printed part. So where do we go from there? We put it inside of the shell of the actual alien. So as you can see, it's right up into the fiberglass, things like that. So we're getting ready to mechanically move it and animate it. So now we had to skin this creature. So we printed over 9 days the entire alien head that Ian Joyner designed. And from that 3D print, we assembled it back together. Because remember, we were only working in a 10-inch square platform. Piece it all together, did a clay press on top of it to get rid of the seams, and then run our silicone, platinum silicone pull off of it, and actually skin the alien together for the final that derived from 100% 3D printed part, which is pretty phenomenal. Because to this day, that puppet is still in our facility with those carpets with the rubber-like teeth still in it. They're still holding up X amount of years later. Now keep in mind, Cowboys and Aliens came out, 2 to 3 years ago? We work on these movies a year and a half before they even come out, so that's an almost 5-year-old printed part still in that head, still holding up today. So, we start moving forward even more. What else can we do? We worked on the Geico Gecko campaign. And at the time, they were doing what was called a Flat Stanley campaign, where they were sending the gecko around all different landmarks in the world, and a film crew would film them in front of the Opera House in Australia and things like this. And we were printing the gecko, and it was boring for us. We had to clean up every little gecko and things like that. It was great that we could do this, but it was a lot of work. How can we streamline this? We had to make like a 20 kit of these things. So we decided, can we 3D print our first mold ever? People were talking that they wanted injection mold things, but we just wanted to run platinum silicone in our studio. Can we get 20 pulls out of a 3D printed tool or not? So we're not going to try to invent how to make a mold. We have a mold department that's been doing it forever, so we're going to bring those guys in because they're the geniuses. Get them more involved in the design process. How can we visually sculpt this tool the way that you guys would want it, rather than us trying to figure it out for you guys and make you unhappy? So after about 2 days, we came up with a 5-part mold for the Geico Gecko. And it was a big time learning curve for us. And then one of the owners of the company, Alan, came up and threw another wrench in the equation. It would be great if we could lay an armature inside of that mold as well and be able to pose this thing right out of the mold. So we went back to the drawing board and came up with a couple more things and put it together. And that's the first 3D printed mold that we ever did. And it worked so well on the first pull that was the first pull out of the mold by just running it inside of our shop. Next problem we had was, okay, we reduced all the flashing, and we were able to accomplish that in about a half a day. We printed the tool, handed it over to a painter, and there it is. Right out of the 3D printed tool, which still is holding up to this day. Fully posable, mouth, head, body, arms, fingers, everything is posable in that mold. So, now it's getting good because all the departments are involved in this, people are getting jazzed about it, and there's still one department that hasn't really been playing with 3D printing with us, and that's the makeup department. All the traditional people that are applying makeup appliances. So, we got a job that came in that we're allowed to use our creative freedom and come up with anything. They wanted to take an actor over time lapse that could transform into 4 or 5 different characters throughout the spot without any editing. And makeup's on, makeup's off type thing. And one of the characters was an alien. And they were running behind, we had like 4 or 5 days to do this, so we just started traditionally sculpting out an alien creature, and then we started digitally making armor pieces in rigid plastics and also clear plastics that we can run electronics through and light. So now we're working with traditional makeup artists and the digital designers up front and 3D printing appliques for them and coming up with this within 2 days. And where did it go from there? When it all came together in the final spot, it's like this.
When I was a young boy, I always knew exactly who I was, what I wanted to be when I grew older. Now I don't know who I am anymore. Now, that is all part of the truth.
We are told how to act, taught how to speak, how to inflect, how to sit, walk, carry tune, hold a fork, hold fire. Learn how to throw a punch, take a bullet, make people cry. Study the lives of others until we've completely forgotten our own.
CG. We love CG. We love practical. We love what's best for the story, what's best for the character, what's best for you guys, the audience, to pull off what you're supposed to be doing. It's not one or the other, it's marrying it. 3D printing is another tool in our toolbox. Everyone thinks when we run in these machines that it's going to take over and put people out of jobs and there's going to be robots everywhere making art. No, that's not the case at all. It's just what works best for the right job. Everyone asks questions about, generic questions about what they see out of these suits. Every one of it's different. Every job, something affects it differently. A budget, time frame, you name it, actors availability. So you got to dynamically figure out how to bring things together to pull it off. And it's great having that tool, that asset there at any time to help you if you need it. So, on top of what you saw in that makeup piece, another problem that started happening was actors availability to bring them in for traditional life casting. Traditional life casting will give us all the detail that we need of an actor or actress's body, but just a lot of times they're not available to get them in so we can start with our craft and move forward. So we started investing in scanning technology. So we started making likeness masks for stunt performers that if a hero actor couldn't pull something off, we needed to put a stunt person in and make sure they look like them, but we needed to get that data first so we could start building. So we came up with some secret sauce techniques that we use. Fly out, Jim and I take photos, hair reference samples, skin color samples, and then I'll scan them in our hotel room, clean up that scan data, send it through VPN from my hotel room to my printer, print out a face one-to-one, hand that over to a traditional sculptor that can bring the detail back into it, and then we'll run our silicones off of that to start making faces. So, what you see here is a 3D print that has been clay pressed over to bring out even more detail to be brought into a silicone and have a mask made, painted, and then punched with hair. And I could spend 6 hours here talking about this process, but from 3D print to traditional sculpting to molding and casting to hair punching, and you get Scotty wearing a Robert Downey Jr. mask based off of the 3D print. But that's within a couple of days you can replicate a person. On the Twilights, we went out and scanned Kristen for a couple of scenes. They wanted us to make some puppets of her. We came up with a clean version, a decimated version.